Hi there, Mr. Sutton here, bringing you the AB Calculus 3-1 homework solutions on the power rule. To figure out the derivative on this problem, we're going to rewrite this without this x cubed in the denominator. So I'm going to use negative exponents. I can write this as negative 5/3 times x to the negative third. And now just using my power rule, negative 3 times negative 5/3 would just give us 5, and then we'll have x to the negative 3 minus 1, so that'll be negative 4th power. For this problem, to figure out the derivative, I'm going to rewrite this radical term here with an exponent. So I'll have negative 3x to the 1/2 power, and then everything else can stay the same. Now going from left to right and applying my power rule, for this first one, I've got 3 times 2 is 6, x to the second. Next, this is going to be, let's see, negative 3/2 times x to the negative 1/2 if we subtract 1 from 1/2. Next, we have minus 5. And then the derivative of 2 is just a constant, so that's just 0. So this ends up being our derivative. For this problem, to find the derivative, I'm going to rewrite these with exponents. So this first one I can rewrite as x to the 1/3 power, followed by, this will be minus x to the 2/3 power. Taking my derivatives now, using my power rule, I've got 1/3, and then I'm going to have x to the whatever 1/3 minus 1 is, so that's going to be x to the negative 2/3, using our common denominator there. Then for this next one, I'm going to have minus 2/3, because we're doing 2/3 times this invisible coefficient of 1, and I'll have x to the 2/3 minus 1, so x to the negative 1/3. For this problem, to take the derivative, these are all just normal power terms, so I don't have to do anything special. Just go left to right and use my power rule. So on the left here, I've got 4x to the third, decreasing the exponent by 1, minus, this will be 3 times 7 is 21, x to the 2, followed by, let's see, 2 times 2, that's 4x to the first power, so just 4x. And then derivative of 15 is 0, so we don't bother writing that. Before I can take the derivative of this one, I'm going to try to rewrite it using just x to some power without any fractions or radicals here. So going from left to right, 7x to the 12th can stay the way it is, but 5/x cubed, I'll rewrite that as 5x to the negative 3rd power, and then this will be x to the 14/5, followed by minus 2x to the, let's see here, this is going to be the negative 2/7. I've got a denominator x term here, so that's going to have to be a negative power. And then 98 is still 98 for what it's worth. All right, going left to right, using my power rule, I've got 12 times 7, which is 84, x to the 11th. Next, this is going to be negative 3 times 5, so negative 15, x to the negative 4, because we're subtracting 1 from a negative number. Next, we've got 14/5, and that'll be times x to the, let's see, 14/5 minus 5/5 is 9/5, so x to the 9/5. Next, we've got, let's see, negative 2/7 times negative 2, that's positive 4/7. Times x to the, let's see, negative 2/7 minus 7/7, so that'll be negative 9/7 power. And then finally, 98 is a constant, so the derivative of that is just 0. To take the derivative of this problem, we're just going to apply our power rule, going from left to right. So for this first term, I've got 8a times 3, which will be 24a, and then we'll do x to the, whatever this exponent is, minus 1. 8a is a constant, so I'm just going to do 8a minus 1, and that'll actually be the exponent. Can't really simplify that any better. For the next one, we've got negative, let's see, 9 times 6 is 54, x to the 8th. And for this next one, I've got negative 28 times x to the negative 4 minus 1, so negative 5. On this problem, to find the derivative, I just have to use my power rule and just be careful with these fractional exponents. So for the first one, we've got 6/5 times 6, that's 36/5, times x to the, let's see, 6/5 minus 5/5 would be 1/5. Next, we've got 10 times 1/5, which is 2. X to the, let's see, 1/5 minus 5/5 would be negative 4/5. For this problem, they're asking for the limit as h approaches 0 of all this stuff. So the key on this one is recognizing that this is the limit definition of a derivative. Basically, they're just asking for the derivative at a certain value of some function. We just have to figure out which function and what they want us to plug in after we take the derivative. So for this one, I'm just going to look at this negative 2 plus h pattern here. I'm basically going to swap that out for x to create a function out of this. So up top, I've got 8 times, I'm going to call this whole thing x. And then downstairs, that negative 2 plus h is being cubed, so I'm going to write x cubed below. And at this point, I'm going to go ahead and simplify this and take the derivative. Now, if you haven't learned the quotient rule yet, really your only recourse is to simplify this thing and use the power rule. So x over x to the third, I can simplify that to x to the negative 2. We still have the 8 there. So using my power rule now to find f prime, I've got negative 16 x to the negative third. And then what am I actually plugging into this? Well, if I look back up here, I've got negative 2 plus h inside here. So that means I'm plugging negative 2 into this derivative. So I'm going to have negative 16, and this will be negative 2 to the third in the denominator, if I just make that a little bit easier to work with. So this is negative 16 over negative 8, which reduces to 2. For this problem, we're trying to find the limit as h approaches 0 of all this stuff. Now this is just the limit definition of a derivative, so we just have to figure out what the original function is, take its derivative, and it looks like they want us to plug 9 into this, because we've got 9 plus h. All right, to write the original function, I'm just going to replace 9 plus h with x. So this is really just the function f of x equals 3 radical x. And in order to take that derivative, I'm just going to rewrite that with an exponent. So 3x to the 1/2. Using my power rule now, this will be, let's see, 3 times 1/2 is 3/2. X to the 1/2 minus 1 is going to be negative 1/2 power. Now they want us to plug 9 into this. So if I plug 9 in here, what I'm really dealing with, if I have 9 to the negative 1/2, this is really 1 over the square root of 9. So I can write this as 3 over 2 radical 9. Well, this is really just 3 over 6, which reduces to 1/2. For this problem, we're given the function f of x equals x, and we want to find f prime of 5. Well, it would help if we found f prime of x in general. So the derivative of x, that's just a line with a slope of 1, essentially. So the derivative is just 1, or you could just use our line rule. So that's just 1 no matter what you plug into it. So if I plug in 5, it's still going to return 1. So 1 ends up being our answer here, choice C. On this problem, we're given f of x and asked to find f prime of negative 1. So I'm going to find f prime of x, then I'm just going to plug negative 1 into it. I'm going to rewrite this in order to make it a little bit easier to find f prime using the power rule. All I'm really going to do is just rewrite this 1 over x term as x to the negative 1. And now let me just go straight through and use power rule. So going from left to right, on the far side here, I've got negative 3x to the second power plus, well, this is just 1x, so just 1 for the slope on that. And then this will be negative 1 times x to the negative 2. Now I'm going to go ahead and plug in negative 1 for all of these. And when I do this, I'm going to rewrite this negative x to the negative 2 as negative 1 over x squared. So we have 1 over negative 1 squared. So going from left to right, this negative 1 squared is just 1, so I just have negative 3 for the first term. Plus 1 gives me negative 2, and then I'm just subtracting 1 over here if I simplify this. So negative 2 minus 1 gives me a grand total of negative 3. Just careful with the sign arithmetic here. So that's choice D. On this problem, we're given the function f of x, this polynomial here, and we want the instantaneous rate of change of f at x equals 3. So basically, they want us to take the derivative of this thing and plug in 3 for x. So let's find f prime of x first. I can just use the power rule on this one. It's a pretty straightforward power rule. So going from left to right, we have 3x squared minus 2 times 6 is 12x to the first, plus this is just going to be 8 because the slope of 8x is just 8. Negative 2 is a constant, so the derivative of that's just 0. So this is what we're plugging in 3 for now. So plugging 3 in for all my x values. I've got, let's see, 3 times 3 squared is 27. This is minus 36, so that's negative 9. Plus 8 gives us a grand total of negative 1. So choice C. For this problem, they want us to find f prime of 4 given f of x right here. So first I'm going to need to find f prime of x. And to do that, I'm going to rewrite this using just normal exponents, and then I'll use my power rule. So this radical x, I can rewrite that as x to the 1/2. And then 3 over radical x, that's 3 times x to the negative 1/2. Now using my power rule, this first term, if I take f prime, this is going to be 1/2 x to the negative 1/2 if I subtract 1 from 1/2. For the next one, I've got negative 3 over 2 times x to the, let's see, negative 1/2 minus 1 is negative 3/2. And now I have to plug 4 in for all of this. So this first term, I can rewrite this as 1 over 2 times, let's see, this would be 1 over the square root of 4. So 1 over 2 radical 4 then. And then for this next one, I'm going to have, let's see, minus 3 over 2 times, this is the square root of 4 cubed. So a little bit crazy here, but if we put this back in radical form, we at least have a shot of simplifying this as much as they want us to. So this first term, this is just 1 over 2 times 2, so 1/4. For this next one, let's see, square root of 4 is 2. Cube that, we get 8. 2 times 8 is 16. So this is minus 3 over 16 when the dust settles. Using a common denominator, I can rewrite this first one as 4 over 16. 4 over 16 minus 3 over 16 is just 1 over 16, which gives us answer choice A. On this problem, we want f prime of 2 given this f of x function right here. So I have to first take the derivative of this function and then plug 2 into it. Using my power rule from left to right, I've got negative 8 times x to the negative 3rd if I do negative 2 minus 1. Next, I've got, let's see, 2 times 1/4 is 1/2 x to the first power. And then derivative of 4, well, 4 is a constant, so that derivative is just 0. We don't have to write it. Now I'm going to plug 2 into all this. I can rewrite this first term as negative 8 over 2 to the 3rd. And then I have plus 1/2 times 2. Well, this is really just negative 8 over 8, which is negative 1. This right here is really just positive 1. So I have negative 1 plus 1, which equals 0. Choice D.